Hello dear students, welcome to this new video from IGCSE with Optimus. Students, in this video, we are going to solve a physics paper from May-June 2025 series for AS level structured questions, and the paper variant will be 22. Students, before we start, note that this paper has some challenging questions for the topics turning effect, electricity and particle physics. So don't go anywhere and watch this video till the end so that you will get all your concepts cleared for these topics. Let's now start from question number 1 in the paper. You can see the question on screen. Question first A, it says that table 1.1 lists some physical quantities. Identify with ticks which quantities are vectors and which are scalars. Now we know that scalars are the quantities which can be expressed only with their magnitude, whereas vectors need magnitude as well as direction. In case of acceleration, it's a vector quantity. It requires magnitude and direction both. Displacement is also a vector quantity. Gravitational potential energy is a scalar quantity. Note that all the energies and work done are scalar quantities. They do not require direction. Speed is also a scalar quantity and temperature is a scalar quantity. So from the list that they have given, there are 2 quantities which are vectors and 3 quantities are scalars. Question B, it says a constant resultant force F acts on a car of mass m. The car moves from rest, meaning initial speed is 0, with constant acceleration A along with horizontal ground. When the car has displacement S, the speed of the car is v. Using the concept of work done on the car, show that the kinetic energy Ek of the car is given by equation half mv square. Now here we have to consider one theorem that is called as work energy theorem. It says that whatever work we do on the body, it is stored in the body as additional energy. In case of car, the engine of the car is doing work on the car, which increases speed of the car. Ultimately, it increases the kinetic energy of the car. So work done by engine is the kinetic energy gained by the car. So we can start like this. Kinetic energy is equal to work done by engine, that is force multiplied by displacement. Now we know the formula for force, it is mass into acceleration, and for displacement, since it is an accelerated motion, we will write average speed into time. Now in case of acceleration, the formula is v minus u divided by t. Since initial speed is 0, u will be 0 and the equation will be v by t. Same way for average speed, it is average of 2 quantities, so it is v plus u divided by 2. Again u is 0, so our equation will be v divided by 2. Substituting these in the equation, we will have mass multiplied by, in place of acceleration, it will be v by t. In place of average speed, it will be v by 2 and time t. Now time will get cancelled and we will be remaining with equation mv square divided by 2, and that tells us kinetic energy is given as half mv square. Next question, the mass of the car is 920 kilogram. At time t equal to 0, the car is at rest. At time 5.8 seconds, its velocity is 17 meter per second. Calculate the kinetic energy of the car at time t equals to 5.8 seconds. So formula for kinetic energy would be half mv square, that's half into 920 into 17 square. The answer is 132940. So on the answer line you can write 1.3 into 10 raised to 5 joules. Next question, between time t equal to 0 and t equals to 5.8 seconds, the work done against resistive force is 4.7 into 10 raised to 4 joule. Determine average output power of the car during this time. Now understand, the engine of the car is doing work for increasing kinetic energy of the car, and at the same time it is also working to against the resistive force of the car. Okay. Now for power we can write as total energy upon time. So it is kinetic energy plus work done against friction divided by time. The kinetic energy is 1.3 into 10 raised to 5 that we have calculated in previous question, and the work done against friction is 4.7 into 10 raised to 4 joules divided by time, that's 5.8. The answer here is 30,517. So we can write this as 3.1 into 10 raised to 4 watt. At time t equals to 5.8 seconds, the speed of the car becomes constant. State and explain whether the output power of the car is greater than, less than, or the same as the output power just before t equals to 5.8 seconds. So before 5.8 seconds, the car was accelerating, its speed was increasing. So engine was doing work to increase kinetic energy plus against the resistive forces. Now since the speed is constant, the engine is doing work only against the resistive forces. So it will not require as much power it needed earlier. So the power output of the engine is going to be reduced. So here we'll write power output decreases because speed is constant, hence no work is done to increase kinetic energy. Question 2, first part, it says define the moment of force about a point. So our definition would be product of force and perpendicular distance from pivot. That gives us moment of force. Question B, it says a tree of mass 270 kg grows out of sloping ground and is supported by a post as shown in figure 2.1. The ground applies total force R on the tree at point Q. The center of gravity of the tree is horizontal distance 1.2 meter from Q. The post applies force F 1800 Newton perpendicular to the line PQ. The line of action of F passes through point P at angle theta to the vertical. P is horizontal distance 1.6 meter from Q. The tree is in equilibrium and all the forces act on the tree are in the same plane. By taking moments about point Q, show that the theta is 25 degrees. So let's first figure out all the forces acting on the tree. The first force that is acting on the tree is from its center of gravity in this direction, that is weight of the tree, which will be 270 into 9.81 because 270 is mass. The second force that is acting on the tree is in this direction, that is coming from the support post, and this is F equals to 1800 Newton. Now for equilibrium we have to apply the principle of moments. In case of weight, we do have the perpendicular distance of weight from the pivot. Q is the pivot point. So we have this perpendicular distance of weight which is 1.2 meter. But in case of force 1800 Newton, we are not given with perpendicular distance of 1800 Newton from the pivot point, that is Q. Now that distance is this line PQ. Okay, so we have to first figure out the distance PQ and then we can apply the principle of moments here. For that, we know this distance over here is 1.6 meter. Okay. Now for our reference, I'll just increase this line, extend this line like this. Okay. So you can understand this angle over here is angle theta, because these are vertically opposite angles. Okay. Now consider this line 1.6 meter. Okay. And this is the line that we have extended like this. This line is line PQ. Okay, and this is the line coming from force 1800 Newton. Okay, now you can see that the vertical line is perpendicular to this 1.6 meter line, and the force line, that is 1800 Newton, is perpendicular to line PQ. So if this angle is theta, then the angle between the two lines will also be theta. We are using a principle here that if the angle between lines is theta, then the angle between their perpendiculars will also be equal to theta. So this angle over here is going to be then theta. This distance PQ can be worked out like this. Cos theta is equal to 1.6 divided by PQ. So PQ will be equal to 1.6 upon cos theta. Now, applying the principle of moments, that is total clockwise moment is equal to total anti-clockwise moment. For clockwise moment, 270 Newton in 270 into 9.81 is producing clockwise moment. So we will write 270 into 9.81 into their perpendicular distance from pivot, that is 1.2, is equal to total anti-clockwise moment is 1800 Newton force multiplied by the perpendicular distance of 1800 from pivot, that is 1.6 upon cos theta. Now to figure out cos theta will be equal to 1800 into 1.6 divided by 270 into 9.81 into 1.2. Now if you solve this, 1800 into 1.6 divided by 270 into 9.81 into 1.2, we get 0.906. So theta is cos inverse of 0.906. This comes 25.04, which is approximately 25 degrees. Okay. Next, on figure 2.2, draw a labeled scale vector triangle to represent the forces acting on the tree. The weight of the tree has been drawn to scale. So here we have to show the vector diagram for all the forces acting on the tree. The one that they have shown is the weight of the tree. So we have to first figure out the scale they have used for drawing this line. So I'll use the digital scale for this. That is, I'll consider this one section as 1 centimeter. So you can see it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and approximately 12.4 centimeter long according to the scale that I am using. So I can write this as 12.4 centimeter is equal to 270 into 9.81 Newton, because it is showing the weight of the tree. So 1 centimeter will be equal to 270 into 9.81 upon 12.4. This gives us answer 213.6 Newton. Now this is our scale. So 1 centimeter is indicating 213.6 Newton. Now the other force which I have to show is 1800 Newton force. For 1800 Newton force, I'll have to show line of length 8.4 centimeter, and this has to be at angle 25 degrees. Okay, so You can see on my scale this vertical line shows angle 90 degrees. So to show the angle 25 degrees, I have to move it to 65 like this, and then I will be drawing the line of length 8.4 centimeter. Like this. So this angle is 25 degrees, okay, and the line that we have drawn is 1800 Newton force. The third line, according to the vector law of addition, the third line is the resultant. So this will be our resultant force, okay, and as per the triangle law of vector addition, the direction is going to be this, okay. Next, the tree exerts pressure of 150 kilopascal on the top of the post. Determine the surface area of the tree in contact with the post. So we are going to use formula for pressure, that is force upon area. So area will be equal to force upon pressure. Here they are asking about force produced by the post, which is 1800 Newton, and the pressure here is 150 kilopascal. So 1800 divided by 150,000, this gives us answer 0.012 meter square. Next, question number 3. It says two progressive water waves X and Y travel along a straight line from point A to point B. The variation of displacement of the waves with distance from A at an instant in time is shown in figure 3.1. So you can see on the diagram that they have given, there are two waves X and Y. Both the waves are having different displacements. X is having amplitude of 10 centimeter, whereas Y is having amplitude of 20 centimeter. Secondly, when there is crest of wave X, there is trough of wave Y. It means the waves are in 180 degree phase difference. The first question is state the amplitude of the wave. So we can write the amplitude of the first wave, that is X, is 10 centimeter. Both the waves have frequency 16 Hz. Determine the speed of the wave. For that we will use formula V is equal to F lambda. So F is equal to 16 and lambda is going to be 0.4. So this will be 6.4 meter per second. Next, state and explain whether X and Y are coherent. So what's the property of coherent waves? Coherent waves, they have constant phase difference. In case of X and Y as well, you can see there is a constant phase difference of 180 degrees, and hence we can say that these two waves are coherent. So we will write yes, they have constant phase difference of 180 degrees. Next, wave X and wave Y superimpose to form a resultant wave. On figure 3.2, sketch the variation of displacement of the resultant wave with distance from A at the instant of time shown in figure 3.1. Now as you can see, these two waves are in 180 degree phase difference, so there is going to be destructive interference. So one wave is going upward with displacement of 10 centimeter, and at the same time the second wave is moving downward with the displacement of 20 centimeter. So the resultant displacement is going to be downward 10 centimeter. Okay, so our first peak is going to be over here and the second would be here. So the resultant wave will look something like this. Because of destructive interference. Next, the intensity of wave X is Ix, the intensity of wave Y is Iy. Use figure 3.1 to determine the ratio Ix upon Iy. Now according to Malus law, we know that Ix upon Iy will be ax square upon ay square. Malus law states that intensity is directly proportional to square of amplitude. So for wave x the amplitude is 10, so it will be 10 square, divide by, for wave y the amplitude is 20, so it will be 20 square. 100 over 400, this will be 0.25. That's the ratio. Question 4, it says a small ball is dropped from rest from the height h1 above the ground and falls vertically downwards. The ball collides with the ground and bounces back vertically upwards, reaching a maximum height h2. Figure 4.1 shows the ball just before and just after hitting the ground. The ball has mass 0.25 kilogram and it is in contact with the ground for time of 0.18 seconds. Just before the ball hits the ground, it has speed 5.2 meter per second. Just after it leaves the ground, it has speed 3.6 meter per second. The air resistance acting on the ball is negligible. State and explain whether the collision is elastic or inelastic. Now, in terms of elastic collision, we know that the kinetic energy must be conserved, and for that, speed must remain constant. In the case of a ball that we are seeing here, the speeds are different. When the ball is approaching, the speed is 5.2, and when it is bouncing up, the speed is 3.6. So as the speed is different, the kinetic energies would be different, and so the collision will be inelastic. So here we will write it is an inelastic collision. Speed changes, hence kinetic energy is not conserved. Next question, calculate the change in momentum of the ball during the collision with the ground. Now the formula for change in momentum is mass in bracket v minus u. Note that here we are talking about velocity, and velocity is a vector quantity. So we have to take in consideration the changes in the direction. Speed 5.2 is downward and speed 3.6 is upward. So we have to take one of the velocities as negative to show that it is opposite to the other one. So mass will be 0.25. The final velocity is 3.6. And the initial velocity I will take as negative, indicating that it is opposite to 3.6. So our final answer would be 2.2 kg meter per second. The next is determine average force on the ball during the collision with the ground. So for average force, we will use formula change in momentum upon time. So change in momentum is 2.2 and the time of contact is 0.18 seconds. So this gives us answer 12.2. On the answer line, we can write 12 Newton in 2SF. Next, calculate the ratio H2 upon H1. Now, when the ball is coming downward, its initial speed is 0 and the final speed is 5.2 meter per second. So we can use formula v square equals to u square plus 2gs, and in place of s we can write h1. So v square equals to 2g h1. Same ball, when it is going upwards, we are given with its initial velocity, that is 3.6 meter per second, and when it will reach to its maximum height, the final velocity will be 0. So here the equation would be v square equals to u square minus 2g h2. Now why we are taking minus here? Because the object is going against gravity, so the acceleration due to gravity will be minus. So we will have equation u square equals to 2g h2. Okay, so for H2 upon H1, we can write U square divided by 2G upon V square divided by 2G. 2G will get cancelled and then it will be 3.6 square upon 5.2 square. The answer is 0.479. So we can write 0.48 as the ratio of heights. Question 5, it says define the Young's modulus. So we can write ratio of stress to strain. So Young's modulus is stress over strain. Question B, it says a wire of unstretched length 0.81 meter. So this is the original length of the wire, is made of a metal with Young's modulus 95 gigapascal. So this is Young's modulus. The wire obeys Hooke's law and has constant cross-sectional area. Figure 5.1 shows the force extension graph for the wire. Determine the cross-sectional area of the wire. So we have the Young's modulus formula. It is F into L upon A into X, where X is the extension. So for area, we can use formula F into L upon Y into X. We can take the value for F and extension from the graph. So let's say we are taking 500 as the force. The length is 0.81 meter, original length. Young's modulus is 95 gigapascal, so it is 95 into 10 raised to 9. And when the force is 500, the extension is 4, so it will be 4 into 10 raised to minus 3 meter. So the final answer is 1.06 into 10 raised to minus 6. So we can write the area as 1.1 into 10 raised to minus 6 meter square. The extension of the wire is initially 2 into 10 raised to minus 3 meter. Determine the work done to increase the extension of the wire to 3 into 10 raised to minus 3 meter. So they are asking us the work done between the two extensions. Here we will first check the forces for the extensions that they have given. So for 2 into 10 raised to minus 3, the force is 250 Newton. So for this the force is 250, and for extension 3 into 10 raised to minus 3, the force value is approximately 375 Newton. So here the force is 375 Newton. Now we are going to use the formula for work done in extension, that is half into F into X. So work done between the two extensions would be half into 375 into 3 into 10 raised to minus 3 minus half into 250 into 2 into 10 raised to minus 3. We get the answer here as 0.312. So for the final answer, we can write 0.31 joules. Question number 6. Define electric potential difference across a component. So electric potential difference is the work that is done by battery to push the charge through that component. So we can write it is work done per unit charge to move it through the component. Question B. A circuit contains 4 resistors and a battery of electromotive force 8 volt with negligible internal resistance. When the variable resistor has resistance R, the currents in the circuit are 0.03 ampere, I1 and I2 as shown in figure. Now looking at the figure, you can understand that 0.03 ampere is the total current produced by battery, and then this 0.03 ampere is splitting in 2 branches, one going in this branch as I2, another is going in this branch as I1. Determine the charge passing through the battery in the time of 4 minutes. So charge is given as current into time. The current produced by battery is 0.03 and the time is 4 into 60. Since it is given in minutes, we have to convert that in seconds. So 0.03 into 4 into 60, we get answer as 7.2 coulombs. Next, calculate the current I1. Now current I1 is going through 2 resistors which are in series, that is 430 ohms and 240 ohms. Always remember that when the resistors are given in series, to calculate the current in that resistor line, we have to add those resistors before calculating the current. So for I1, we have to write V upon total resistance in series. So 8 divided by 430 plus 240. Here we get the answer as 0.012 ampere. So out of 0.03, 0.012 is going in this branch. So remaining will be going in this branch, that is I2. So I2 will be 0.03 minus 0.012. This is 0.018 ampere. The next question they are asking is determine the resistance R. So we have to find out the resistance of variable resistor here. Again, the current that is going through both of these resistors is 0.018. So what we have to do is first we have to calculate the total resistance. So total resistance will be voltage upon total current, that is I2. Voltage is 8 and the current is 0.018 ampere. This gives us answer 444 ohms. So value of R will be 444 minus this resistance value, that is 210. This is 234 ohms. Okay. Next, the variable resistor in B is fitted with a scale so that its resistance can be accurately determined. The resistor of resistance 240 ohms is now replaced by a new resistor X of unknown resistance. A galvanometer is connected as shown in figure 6.2. With reference to the ratios of resistances, explain how this circuit can be used to determine the resistance of X. Now to determine this unknown resistance X, we have to use something called as null method. In null method, when the galvanometer reading will be 0, the resistance ratios in a particular branch matches with the resistance ratios in the another branch or the parallel branch, you can say. So we can write here, when the reading on galvanometer is 0, the ratio of resistance in each branch will be equal. So consider the resistance on variable resistor as RV. So 210 upon RV is equal to 430 upon x. So if RV is known, we will be able to find out the value of unknown resistance x. Question number 7. A, it says state what is meant by a fundamental particle. So we can write particles, those cannot be further divided, are called as fundamental particles. A nucleus X has 14 nucleons and p protons. The ratio of charge to mass for nucleus X is 4.1 into 10 raised to 7 coulomb per kilogram. Determine P, that is number of protons. Note that they have given us 14 nucleons, so the total mass of the atom in kilogram, of the nucleus in kilogram, will be 14 into mass of one nucleon, that is 1.66 into 10 raised to minus 27 kilogram. Okay, so 14 into 1.66 into 10 raised to minus 27 kilogram gives us answer 2.32 into 10 raised to minus 27 kilogram. Okay, now this one atomic mass unit is given over here in the data sheet. So from here you can take this value 1.66 into 10 raised to minus 27 kilogram. Now next, the charge upon mass ratio that they have given is 4.1 into 10 raised to 7 coulomb per kilogram. Okay, so the total charge will be equal to 4.1 into 10 raised to 7 multiplied by 2.32 into 10 raised to minus 26. This comes 9.5 into 10 raised to minus 19 coulomb. So this is the total charge present in the nucleus. Now note that in a nucleus only protons can have charge, neutrons are chargeless. So all this charge is borne by protons. So the number of protons will be equal to the total charge, that is 9.5 into 10 raised to minus 19 upon the charge on one proton, that is 1.6 into 10 raised to minus 19. This gives you answer 5.9, but since we are talking about protons, it has to be a whole number because charge is always quantized in protons. Okay, so it has to be 6 number of protons. Now nucleus X undergoes beta minus decay to form nucleus Z. Complete the equation representing this decay. So here the number of protons is going to be 6. Since it's a beta minus decay, we will first write the beta particle. Here it will be minus 1, that is charge, and the mass will be 0. In beta minus decay, mass remains same but the proton number increases by 1. So Z will have proton 7 and the mass will be same as 14. And along with beta minus there is also anti-neutrino that comes. So it will be indicated like this. Question C. A sample of a radioactive substance emits particles that are positively charged and have the continuous range of kinetic energies. State and explain whether the nuclei in this sample are undergoing alpha decay, beta positive decay, or beta negative decay. So since the particles coming are positively charged, it has to be either alpha decay or beta positive decay. So beta minus decay will definitely not be an answer. Now talking about the alpha decay, in alpha decay we don't get continuous range of energies, we get discrete energy packets coming out because there is only one particle coming, that is alpha. But in case of beta plus decay, along with beta plus there is also neutrino coming out, and so the energy released is shared between beta positive particle and the neutrino, and that's why we see range of energies. Okay, so it has to be beta positive particle as it is positive, and second, it cannot be alpha, as alpha has discrete energy emission. Okay, that means in fixed values, not in the continuous range of energies. Okay, so students, that sums up our second paper in MJ 2025 series. If you have any queries about the paper that we have just discussed, feel free to drop those queries in the comment box and I will be happy to answer all those questions. Students, don't forget to share this video with your friends and like and subscribe to our YouTube channel for more such videos on A levels and IGCSE. Thank you.